G'day, Michael here. On this gloomy old day, you can see, if you've been following what I've been up to here, I've cleared out and leveled that area with the loader. We've now laid concrete on, on the ground, and the drainage has worked out quite beautifully. As you can see, I'm mostly through the first course of what's called Besser blocks. I'm sure they're called something elsewhere overseas. But what came to my mind is some basics about retaining walls. Now, I'll just step back, get a better overview maybe. In behind everything there, you can see like the timber retaining wall. Now, when I did that 8 years ago, it was always intended to be a 5 to 10 year plan. Well, we've 8 years passed, so I'm right in the middle of that. So we're pretty well bang on schedule for this replacement. Now, timber was actually very quick for me to put in. I did that timber wall in 2.5 hours on my own with the Kanga loader. Now I'll explain what I actually had to do there. And that is, each one of those posts that you can see here has been sunk into the ground around about 1 metre or a yard in the old currency. And these posts are local hardwood, as are the joining rails, I guess you'd call them. And very strong timber, reasonably good for weather resistance. But nonetheless, you can see that there's some breakdown of the timber, even though I treated it with a wood treatment to prevent fungal ingress. But nonetheless, it still happens. So it's a biological material, and microbes soon reclaim everything you put in. Okay, now with retaining walls, there's some basics to understand, and that is that land is not solid. Think of it as a very stubborn liquid. So it flows down slowly, goes with gravity, a bit like a glacier really, but it's near impossible to push back up again. So all you can do is do your best to hold it. And this being decomposed granite, and decomposed granite, the next stage along is more or less a clay. As it fills up with water, it expands. As it dries out, it shrinks. So it kind of has a ability to force things apart. Now the timber posts I put in have held up really beautifully for 8 years. They would certainly not last 800 years. They haven't got that kind of lifespan in them. Okay, so with building for fluid pressure, obviously the higher, this is fluid pressure we're talking about really, but it will not bend back. Like if you have a tank of water, the water inside remains flexible, whereas ground, earth, does not. It's stubborn, you can't push it back. You can see a little bit of failure here. Maybe you can see it, I'm hoping I can demonstrate it. The post in the centre of the picture has actually started to go upright. I did have all the posts leaning into the hill. I don't know how to show it. That's about the best I can show it. So this area here has suffered a lot more pressure than other areas, and certainly the footing for the post may well have also given in a little bit. Now, when I did this concrete slab, the chap I had organised to do the main part of the concrete slab, he suggested that I put these steel bars as concrete reinforcement, so that these blocks could be concrete filled, and in effect it'll be solid concrete columns going vertically. Now these concrete columns are going to be a very, very strong part of the wall. Now initially I was thinking about having the concrete slab on its own and then doing something separately for the wall. But when he suggested to run the reinforcement steel straight up from the slab, I thought, well, that's a great idea, because there's no better way of building a footing for the retaining wall when you consider how high the pressures are involved. Now I'm only going 3 blocks high, which is about 2 feet in our currency, or 600 mil in metric. And the centre layer, which is not yet laid, has a kind of a channel in the blocks. Perhaps I'll get one of those blocks. Okay, so here I've temporarily laid one of these blocks in place, and there'll be halved over the lower bricks, exactly like you do any other brickwork. And as you can see, there's the holes going vertically with the reinforcement bar going straight through. Now that will obviously later be filled with concrete, but the channel here allows me to run concrete horizontally along this line of bricks. So basically the whole run, the whole wall, will be reinforced its full length laterally as well as vertically. So the result is going to be quite a strong wall. Whereas, just laying the blocks held together with mortar would have very little resistance against that relentless fluid pressure from the slope, from the earth above. Okay, so the higher you go with the retaining wall, the worse this pressure gets, and it's quite exponential. I don't know the numbers. If you are intending to do a high retaining wall, talk to an engineer suitably suitably trained for this kind of these kind of stresses. Do not just think you can put a 10 feet high brick wall and expect it to hold earth in. That will not do the job. I'm expecting this wall to be reasonably sturdy and capable of holding this pressure. It's not going to kill anyone if this wall fails, but in any case it's a hell of a lot stronger than a typical brick wall. Brick walls typically don't have any tensile strength whatsoever. This will have quite a lot of tensile strength because of all that steel. Yeah, well, I think that's all I need to say now. Maybe I'll do another video when we're done. But that's it for me now. Feel free to like, share, subscribe, ask a question, leave a comment. That's it. Bye for now.